Hi, I'm Sai Krishna. So let us look at question number 7. In question number 7, we are given z of t as a particular equation, and then we are told that theta is uniformly distributed between 0 and 2 pi. We're also given that n1 of t and n2 of t are weights and stationary WSS, and n1 of t, n2 of t, theta, and these are basically all are independent of each other. In part A, we are so let us look at A, B, C individually. First, let us look at part A and solve it. So, question number 7. In question number 7, we are told to find the value of expected value of z of t. So, expected value of z of t. So, expected value of z of t is, first of all, z of t is given as n1 of t, n1 of t cos of omega c t plus theta plus n2 of t sine of omega c theta into t plus theta. Yeah, so this is basically given from the equation I've just substituted in the z of t thing. Now expected value of, let us separate the this term and this term and try to solve it individually. Cos of omega c t plus theta plus expected value of n2 of t sine of omega c t plus theta. This can be written as expected value of n1 of t into expected value of cos of omega c t plus theta plus e of n2 t into e of sine of omega c t plus theta. So we know that e of n1 of t is equal to neta 1 and e of n2 of t as neta 2, which is mean 2. Yeah, so neta 1 into e of cos omega c t plus theta plus neta 2 expected value of sine omega c t plus theta, which is equal to neta 1. So for this expected value, as it is uniform between 0 and 2 pi, I'm integrating it between calculating the average value. So 1 by 2 pi integral of 0 to 2 pi cos of omega c t plus theta d theta plus neta 2 sine of 1 by 2 pi integral 0 to 2 pi sine of omega c t plus theta d theta. Okay, so here we can write as neta 1 into 1 by 2 pi cos integral is sine, so sine omega c t plus theta between the integral 0 to 2 pi plus neta 2 1 by 2 pi sine of omega c theta is equal to minus cos theta, so cos of t theta, and I'm reversing the integrals, so it will become positive again. So it is neta 1, so basically this interval turns to 0, so 0 plus neta 2, this interval also turns to 0, so it is also 0. So neta 1 into 0 plus neta 2 into 0 is equal to 0. Hence we can write expected value of z of t as 0. In that way we have calculated the part A. Now let us look at part B. So 7b. In 7b we are told to find the autocorrelation RZ of T1 comma T2 and check if Z of T is WSS or not, which is wide sense stationary or not. So we can write RZ of T1 comma T2 as expected value of Z of T1 into Z of T2. So this is expected value of Z of T1 is N1 of T1 cos of omega C T1 plus theta plus into T1 sine of omega C T1 plus theta. This is basically the first equation, and also T2. So N1 T2 cos of omega C T2 plus theta plus N2 T2 sine of omega C T2 plus theta. Okay, yeah, got it. So let us separate the like terms first. So this becomes N1 of T1 cos of omega C T1 plus theta into N1 T2 cos of omega C T2 plus theta. This is a term, and the other term is N1 T1 cos of omega C T1 plus theta plus N2 into N2 T2 sine of omega C T2 plus theta. And this is one term, and let us write the third term, which is N2 T1 sine of omega C T1 plus theta into N1 T2 cos of omega C T2 plus theta. And now let us write the final term, which is E of N2 T1 sine of omega C T1 plus theta into N2 T2 sine of omega C T2 plus theta. So let us now simplify these equations. So which is, we know that E of N1 square T as Rn1 tau T2 as, so similarly we can apply to this on this equation. So this becomes Rn1 of tau into expected value of cos of omega C of T1 plus T2 plus 2 theta. Okay, there'll be another term cos of omega C tau. Okay, and the other is neta 1 neta 2 E of sine of omega C T1 plus T2 plus 2 theta minus sine of omega C tau plus neta 1 neta 2 E of sine of omega C T1 plus T2 plus 2 theta. This is one term, sorry, I have not put the brackets, plus sine omega C to tau plus Rn2 tau of expected value of this is basically cos of omega C T1 plus T2 plus 2 theta minus cos of omega C tau. So we can clearly see that this becomes 0 and this becomes 0. Okay, and and we can see that Here this becomes equal to half of, because the expected value of this becomes half, so half of Rn1 tau plus Rn2 tau into cos of omega c tau. This becomes the solution, which is equal to which is the answer, and hence we can clearly see that z of t is a WSS. So hence we have solved the equation, hence we have solved the part B in this fashion. So let us look at part C. In the part C, we are told to calculate Rg of 0. From the last equation, we can see that Rg of 0 can be written as half of Rn1 tau plus Rn2 tau, and in this place, this is tau, so Rg of 0 becomes half Rn1 of 0 plus Rn2 of 0, which can be written as half of E of n1 square t plus E of n2 square of t. So this is the answer for part C. In this fashion, I have calculated the value of C, if z is an WSS, which is wide sense stationary. So in this fashion, I have calculated A, B, C. Thank you.